So hi all, we are going to see how we can draw a PCB layout using Proteus. So I will be using this circuit for demonstrating the Proteus software. So this is an unstable multivibrator using 741 IC. So let me draw the circuit using the Proteus, then I will show you how to draw the PCB layer. So initially we need to draw the circuit layer. For that we need to open the Proteus, and in the Proteus you can choose the new project option. So let me click here. In the new project option you can give some name. So let me give it as a stable multivibrator, and you can give the path also. Then select the new project option, then give next, then choose default option. In the create a schematic option, choose the default if you want, or you can choose an A4 size paper, no issue. So let me choose the default first. So go for the next. Again we need to create a PCB, so we need to choose the create a PCB option here. Again let me keep it as default. All the settings I am keeping it as default. Then since we are using only op-amp, we now need to use the firmware. So I will choose the no firmware project, then next, then finish. So you will be getting the option or settings for drawing the schematic. So in the Proteus there are two options. Either you can draw the circuit, then you can convert it to PCB. So that I am going to do right now. So first I need to draw the circuit schematic. So for that we need to use this Schematic Capture option. So here we have to draw the circuit. So in order to draw the circuit we need these many components. So initially we need to select all the components. So we need to have an op-amp, then 3 resistors and 1 capacitor. So let me choose it from the Proteus. So for choosing the component you have to go to the library in Proteus. So that is in the option here. So click on the P button here. So it will open the library for choosing the components. So here you can search for 741. Then within that you can get the 741 IC. So whenever you choose a component, check whether the PCB layout is available with that. Okay. So here for the 741 we have that PCB layout here in the library. So we can choose that particular component. So let me double click on that. So you can see when I double click, it is added to the library in the schematic. Then we need resistors. So again you can search for resistor here. Okay. So in the resistor we'll be going for quarter watt resistor, that you can get it from the generic option at the subcategory. Again when you select that resistor, go for the PCB. So again double click, you can see the resistor is added here. Then next component we need is the capacitor. So capacitor we can search it. Okay. Again in the capacitor you can have different types. Among that, in the multivibrator circuit we will be using electrolytic capacitor, that disc shaped capacitor. So you can get it again from the generic. Generic means all the general purpose capacitors will be available. So let me select that generic. In that you can see different types of capacitors. Among that I am selecting the capacitor electrolytic. Okay, you can see generic electrolytic capacitor. Again check whether the PCB layout is available. Okay, so it is there. Then select that. So apart from that we need power supply connectors as well as connectors for taking the output. So power supply we will have positive and negative pins. So we need to choose a connector with 2 pins. Similarly for output we should have connector with 2 pins. So that again you can select it by searching for connector. Okay. So in the connector we will be using the subcategory SIN. Okay. Among that you can see different types of connectors with different pin numbers. Since our requirement is for 2 pins, so we can use the SIL with the 2 pins. So it is shown here the corresponding PCB. So let me select that. So by that our required components are selected. Now the next step is drawing the circuit. Okay. So let me close this library option. Now let me go for drawing the circuit. So initially I am taking the op-amp. Just click on the op-amp within the library and place it within that blue colored box. That is a boundary of your sheet. Okay. So just click anywhere on that. Okay. If you want, you can zoom it. No issue. Just scroll the mouse. Based on that, you can zoom in or zoom out. So let me zoom in for better view. Next, after that, we need this resistor. So this one is the first resistor. So let me connect resistor between pin number for inverting terminal. Pin number is 2. So here it is 2. So before that, let me flip this op-amp. For flipping that op-amp, you can right click on that, then you will have the rotation option and the flip option. So here I am flipping it across the horizontal axis, so that will be like this. Then I will place the resistor here. So just select that resistor and you can place it anywhere on the sheet. So I am placing it here. Then we need to provide the connection between the resistor and the op-amp. So keep the mouse pointer at the terminal. You can see a small red color square. Just click at that point, then move your mouse up to that resistor connector. Okay. So just click over there. The next connection is from this terminal to the 6th pin of op-amp. Then let me change the name of the resistor to some RF. That means feedback resistor. Normally we put the name as feedback for this resistor. So this R and done on the Proteus. So from 2 to 6 I have connected one resistor. Then we should have a resistor here between the pin number 6 and pin number 3. So go for that. Again click on that. Then pin number 3 and pin number 6 I think. So if you want to rotate this component, either you can press the plus or minus button on the keyboard, or you can place it over there. Then you can right click and rotate. Okay, any method you can follow. So I'm doing the option available here. Then connecting it between pin number 6 and pin number 3. Okay. Then the next one is R2. R2 will be here. Again I am rotating. It is connected between the R1 and ground or with the capacitor. Okay. So let me put the capacitor here. That is between pin number 2. Capacitor, when you place the capacitor, check for the polarity also. Since electrolytic capacitor is having polarity, please take care of that polarity of the capacitor. So the connection is something like this. Okay. So I think all the connections have done, the basic connections. Then next things are the power connection. So in order to provide the positive and negative terminals for the power, we can choose the connector. So 2-pin connector I am using. So let me keep the connector here. Okay. Then again let me flip it for a better view. Then for pin number 1 of the connector, connect it to okay. So our positive connection is to the pin number 7 and negative connection is to pin number 4. Okay. Then output, again we have to use a connector. So let me keep the connector here. Okay. Output is taken from pin number 6. Then the second pin is to the ground. Okay. Again, for providing the ground, we can go for the terminal option in the Proteus. So that is here. To the left, you can see an option terminal mode. Click over there. Then you can have the power and ground connection. Okay. Power means normally our VCC. So that we can give on to the pin number 1 of the first connector. So that I am connecting over here. That represents the VCC, positive terminal of the battery. Then the ground should be connected to the second terminal of connection as well as to the output. Okay, so I am connecting it here. Ground. So by this our entire circuit is over. So by this our circuit is over. Next we need to draw the PCB layout. Okay. So in order to draw the PCB layout, we need to choose the PCB layout option in the Proteus. So that is ARES window. So click over that. So when you click in the PCB layout, you can see the components that are used in the circuit will be listed within the library of PCB layout. So all the components are listed here. Okay. Now we can draw the PCB. Okay. So before starting the PCB layout, first we need to define the size of the PCB. For defining the size of the PCB, we can choose the 2D graphics box to the left side. So click that. Then just draw a square within that window. So let me draw a square like this. Okay. After drawing that, right click on the border, then change layer to board edge. Okay. So when it changes, you can see a yellow colored box. So this will be your PCB. You can resize the PCB according to your requirement. No problem. Okay. So after drawing the board, next we need to place the component and we have to draw the PCB layer. Okay. So there are two methods for drawing the PCB and placing the components. Either you can go for manual option or you can go for the automated. Okay. So first I will show you how you can do the automated PCB layout drawing. So for that you can select the tools. In the tools there is an option auto placer. Click on that. Then you can select which all the components that should be placed automatically. Okay. So based on that you can put the tick mark. So I am selecting all the components here. Then you can keep all the other settings as it is. Then just click on the OK button. You can see the components are placed here. So this is an automated process. After that you can change the way in which you want the components to be placed. Okay. For that what we can do is just click on that, then move the components according to our requirement. Okay. So this is a method, automatic method. Otherwise what you can do is you can pick each components and place it over the circuit board. Okay. Both ways you can do that. So let me rearrange the component for the time being. So all these placings, everything you can do it according to your wish and your requirement. So let me keep all the resistors together for a better view. Okay, so I have just arranged all the components and going for the PCB layer. Okay. So in the PCB layer you can see there are green lines connecting the different pins of the components. These green lines are representing our actual circuit connection. Okay. So these connections are represented as green lines in the PCB layer. Okay. This is just for understanding where each component is connected. Okay. Based on that, we have to draw the PCB layer.